Welcome to the next lecture of microwave communication, microwave engineering. In today's lecture, we will study something called S-parameters because S-parameters are important to microwave components in the similar way H-parameters, which you have studied in network analysis, or Y-parameters or even Z-parameters are important to the usual analog circuits. Okay. So basically, broadly, we can say we have studied till now rectangular waveguides. Okay, rectangular waveguides, and also we will be. I will give a brief introduction later on circular waveguides. Okay, circular waveguides. But in practice, you will have something called microwave hybrid circuits. Microwave hybrid circuits. Okay, so it is like if you see the transmission lines, we have transmission lines, we have then several connectors. In the same way, suppose you may have a microwave hybrid circuit like this. Okay, this is also called E-plane T. E-plane T. We'll see it later on what it does actually, but empirically we can see that it has several something called ports. I will call this port 1, port 2, port 3, and what can happen is you can have electromagnetic wave source at any of these ports, and correspondingly some of the waves will get reflected along this wave path, transmitted, some waves will get transmitted along this path, and this can be used in various applications in microwaves. Similarly, you have another device called H-plane Ts. Okay, H-plane Ts like this. So it will have basically, why it's called H-plane T, it will have magnetic field in this direction. Similarly, E-plane waves means it will have electric field in this direction, that we will see. First observation is that they are basically combination of rectangular waveguides only. Okay, you just have, you are cutting a rectangular waveguide, putting one more rectangular waveguide, and you get such T's. There are more examples like something called, I will show you later on in detail, magic T. Okay, and then there are some microwave hybrid circuits, we call them, which are related to circular waveguides. Like we will have what is called hybrid ring. Okay, then there is something called circulator. We'll see it later and how many we can do, but right now we want an equivalent two-port theory as we have in network theory. Let me recall the two-port device from a network theory. Two-port device, any device. It can be a simple amplifier, okay, it can be any other circuit, amplifier coupled with some other circuits. It can be even simple RLC circuit, and with the help of these two-port parameters, you can characterize the circuit. So two-port device is, I will put it here as a black box. Two-port. I'm just recalling you the basic concept from network theory, from which we will get some idea how we can do similar analysis for microwave hybrid circuits. Okay, so now onwards, it should be clear to you what does a microwave hybrid circuit means. In one sense, you can think of them as, some combination of waveguides. Okay, different rectangular waveguides को आपने mold किया है, T shape दी है या कोई और shape दी है, and in such a way that electromagnetic waves, definitely T modes and TM modes, they get transmitted along different paths in a particular fashion, which we will see. Okay, now here is a two-port device. This is the input and this is the output here. Let the potential difference here be V1 and the current here be I1, and the current here it is I2 and it is V2. The convention that we show direction in this way. Now there are several parameters. One of the famous parameters which you might have done, and also they are useful in transistor analysis, H parameters. What is the relationship? So we have like this, V1 is This is the H parameter relationship. It relates V1 with I1 V2 and I2 with I1 V1. Similarly, you have Y parameters and Z parameters. I will not write them here. So there are several such these three are very famous. So we are not going to do it. I was just giving example. Now how do you sorry, now how do you basically compute the H parameters? Suppose if I give you a practical circuit and you want to compute, so just look here. Suppose I want to compute H11. So you can see that what we will do is, if we short circuit, okay, that is we will put I2 to be 0 here. Oh, no, sorry, V2. Okay, I think it is typo here. Wait, it is here V2. Okay, so if I put V2 equal to 0, then I get H11 as a ratio of V1 or I1. Put V2 equal to 0. So putting V2 equal to 0 is equivalent to short circuit at the output. Okay, and similarly, if you want, suppose H12, what you can do is, it is V1 by V2. Okay, and when I1 is 0, I1 0 means it is open circuit. Now here is one important line: we don't use H parameters or any of such parameters in microwave hybrid devices. Okay, why? The reason, there are several reasons. Sorry, see, you have to think about it. You are not having any current source as if you are connecting a wire. It is a microwave source. So there is no equipment by which you can measure a voltage of microwave. You can measure a current of microwave. Okay, so there are some sophisticated equipment, they are not readily available. So this is not feasible in our labs, in our experiments. The other thing is that it is very difficult to achieve a sort of short circuit and open circuit at microwaves at very high frequencies. In fact, the meaning of short circuit and open circuit is not so clear here also. And the other reason, even if you somehow manage to have a short circuit or open circuit, then if you use active devices, suppose we have power transistors, or you use tunnel diodes, they will not be stable, because you are going to use at least power transistors of microwave range in these cases. So they are not stable for short or open circuit. Okay, so in some nutshell, we need some other method to characterize the microwave hybrid circuits to overcome these problems. See, we have to take one care. See, so we are dealing with wave. That is important. We are not dealing with directly current and voltage. We are dealing with wave. So a logical variable will be to use traveling waves. Okay, traveling waves as as a parameter rather than voltage or current. The meaning will become clear further. And such parameters which characterize the microwave hybrid circuit with the help of traveling waves, these are called S parameters. Okay, as an example, let me show a two-port network for microwave. Okay, so it can be anything. It can be what I have shown you, that it can be E plane T, it can be H plane T, it can be magic T, or any other microwave hybrid device. I represent it here with this two-port network, and I will represent here a source, the input electromagnetic wave source with equivalent voltage. I call it VG. Okay, waveguide voltage, and an equivalent resistor. This is actually related to the intrinsic impedance or the impedance of waveguide. I will call it ZG. And here comes the input here, and input here. Okay. Similarly at the output, so there will be similar intrinsic impedance associated with the load. Let's denote that by Z0. Okay. And the incident waves, the traveling waves coming at the input of any two-port network representing microwave circuit, we denote that by letters A and B. So here I denote with A1 the incident wave, and here B1 the reflected wave. Microwave hybrid devices can have edges, okay, can have some reflections in between. So there can be reflection, and so part of a wave may be transmitted through the device, or part of the wave may be reflected. So B1 by B I represent part of a traveling wave which is reflected back. Similarly here A2, okay, the convention is to show this direction, and B2 is what is coming out of the circuit. Okay, and I represent here with S11, S12, S21, S22 as the S parameters, and here are the relationships. So one is the B1, what is reflected out at the input, is equal to S11 times A1 plus S12 times A2. Similarly B2, what comes out of the circuit is S21 times A1 plus S22 times A2. So basically A1 and A2, they are the incident waves coming to the junction, and B1 and B2, they are the reflected traveling waves coming out of the junction. And S parameter, the convention is, the definition is, we write here the reflected parameters, reflected wave parameters, and how they depend upon the incident wave parameters. Okay, so these are called S parameters. So I have shown you here just a simple two-port parameter, but there can be n ports. Okay, as an example, I will draw here magic T. Rather, I have copied directly. You see, magic T is like this. So you have a rectangular waveguides connected in this way. Okay. Now it has 4 ports, as you see, right? So in general, theoretically, there can be n ports. We will see later on something called hybrid ring that has lot of ports, or a circulator. Circulator has 4 ports, or it can have even more than that. Circulator looks like something like this. Okay, so this is port 1, this is port 2, this is port 3, this is port 4. Basically what port means, you can have incident electromagnetic waves at any point of these ports. Okay, and then correspondingly you will have the reflected or the transmitted waves coming out of different ports. So we will write S parameters for general ports. So here I first of all draw an n port circuit, n port microwave junction. Sorry, so here is the example of n junction, n port microwave junction. Okay, it can have n such different ports, as in magic T. This is the magic T. It has 4 ports. So A1, sorry, it is here, I think B1. Okay, A1 is the incident wave, B1 is the reflected wave here. A2 is the incident wave, B2 is reflected wave here. Now the convention will be AJ will represent the incident traveling wave. Okay, coming toward the junction. Okay, similarly we have BI, and that will be the reflected traveling wave coming outward from the junction. Okay, sorry, my microphone was muted, so I will repeat. So here is a general relationship of n port S parameter for n port microwave junction. If you are confused, you can repeat, you can put n is equal to 2 and you will get back what it is. See this, what is Sij here? Sij is sometimes reflection coefficient gamma ij. How? Let me come here. You see this S11. What is S11? S11 is B1 by A1 when A2 is not there, right? What is B1 A1? B1 and A1. A1 is the incident wave and B1 is the reflected wave at port 1. See, reflection you consider when you are at same port. Now look at S12. So S12 is related to with B1 divided by A2. So this is the ratio at different ports. The reflection of one incident wave at one port cannot happen at other port, right? So wherever you have S11, S22, S33, that is I is equal to J. That is what I say, I is equal to J. Wherever you have actually SII type of S parameters, they are reflection coefficients actually. Okay, we will see it with examples also. Similarly, Sij can be transmission coefficient. You know that if you have any surface and there is an incident electromagnetic wave, part of it will get reflected, part of it will get transmitted depending upon the medium. Sometimes it is perfect reflection, sometimes it is perfect transmission. Just compare it with mirror. Okay, if you have usual glass without any mirror, so part of the wave gets reflected, part gets transmitted. So the transmitted part is characterized by the transmission coefficient. So Sij can be transmission coefficient if of of jth port if I is greater than j. Okay, so if you have, whenever you have doubt, go to 2 port. Now look at here. So it is here Sij. Now let me take S21. What is S21? S21 is B2 by A1. B2 is here and A1 is here. So S21 is related to the transmission capability. You see, A1 is the incident wave, B2 is actually outward wave coming out of the this 2-port microwave hybrid circuit. So wherever you have Sij and I is greater than j, like S21, S32, S42, these are all related to transmission, forward transmission. Okay, so it is forward transmission coefficient. And it can be sometimes reverse transmission coefficient. Notation is same, but sign will be different. You will see it later on. If I is less than j, reverse means come back to again 2-port. Suppose you take S12. It is related as B1 by A2. What does it mean? You see, B1, your actual incident wave is A1, but this S12 comes out to be as if A2, which is the incident wave here, and B1, but actually B1 is the reflected wave, right? And A2 is actually what will get transmitted, but I have shown direction here. By convention, direction is shown as it is going into the circuit. So this is called a reverse transmission coefficient. Okay, so we will see it with examples what exactly it means. Right now I want to set up some notation and some definition. Like I will again write in detail and the relationship between A1, B1 and S parameters like this. So here is B1 is equal to, and B1, B2 and so on. I will write here Bn is equal to Sn1 A1 plus Sn2 A2 plus Snn An. Okay, so we can basically then do one thing. We can represent this as one vector. I will call it B vector. Okay, write like this, B vector is equal to, and then we can define S matrix, and then we can also define A vector. So A is also a vector, A1 to An, and we will come up with S matrix like this. So this is actually bold. I cannot write it in the book. You can see S11, S12, S1n, S21, S22, S2n, S11, SNN. Okay, these are actually called, it has a name why it's called S. They are actually called scattering parameters. Okay, or scattering coefficients. Out of H parameter, Y parameter, Z parameter, S parameter are look somewhat similar to Z parameters. You all should recall how Z parameter defined. It is defined like this. So Z parameters V1 is this is how Z parameters are defined, right? So you can compare V1 and V2 with B1 B2 and I1 I2 with A1 A2. Then Z11 Z2 are comparable with S parameters. And in fact, wherever I have drawn this junction, we can also have a notion of impedance, right? So because we know how to compute impedance, you divide the electric field intensity with the magnetic field intensity in that direction, you will get something called intrinsic impedance related to that. So let that be Z01, Z02, Z0n. So every port, correspond to every port, we can have a notion of impedance also. Hence, we can also write then Z parameters corresponding to those impedances in this way. I can write Vi is equal to, this is just a corollary, Zij Ij for I is equal to 1 to n, and again in matrix form, V1 up to Vn is equal to Z11, Z12, Z1n, Z21. Okay, or we can write V is equal to Zi. Again, these are the bold letters, right? Now, based on this matrix definition, next class we will study some properties of Z parameter, some important properties. Those properties will be very useful for computing S parameters of various microwave devices. Then we will take very simple microwave, as I told, junctions like T junction and E plane T and H plane T. Then we will see magic tree, and there is one thing called hybrid ring, that's called rat race circuit. Okay, so we'll take those simple circuits and compute the S parameters. Okay, thank you for that.